Continuing with a topic that kind of scares a bunch of engineers, especially the ones who have the chance to work, especially in software architecture. We have Bruno Škvorc today who will talk to us about auditing code for security flaws, especially the big ones.
Yeah.
Stage is yours.
Thank you. Okay. Hello, everybody. Nice, intimate atmosphere. I hope this means that everybody's going to be willing to ask some questions at the end, because it tends to become interesting. So we'll talk about auditing smart contracts and, in general, smart contract security a bit, but not. I'll focus halfway on code security and halfway on actual engineering social approach security. And I don't mean social hacking as in cheating someone into giving you their password, but actual malicious design. And you'll see what that means a little later. Let me just present myself real quick. This is in the way. You can find more information. Where's the slides? The slides are missing. All right, cool. Now we can go. So you can find out more on these links. I'm a guy who wears many hats, basically. And the one that I'll be talking about today is the third one, audits, forensics, and development at auditor.io. I actually work on the Ethereum 2.0 protocol with a bunch of other very smart people. And we're developing the next generation of this powerful blockchain. And we will be focusing on blockchain today. So sorry if you got the wrong impression or something. Specifically, I work on Nimbus right now, which is a client for the Ethereum 2.0, and that's being developed to work on very resource-restricted devices. But we'll talk about security in particular. So before we dive into auditing smart contracts, we have to kind of consider what an audit is, actually. And I think that's kind of the same across any industry, across any stack, blockchain or not. You have security audits that basically amount to a pile of papers that someone else wrote for you and put their opinions about your code in there. These opinions can be mathematically backed. They can be analyzed from a computer science perspective. They can be analyzed from a social perspective. They can be analyzed from both. But in general, you get a bunch of opinions from a bunch of people about your code and what's wrong with your code or could be wrong with your code, and then you're expected to fix this or to submit it to shareholders or your investors or whoever else. So why audit smart contracts? Well, we all know that smart contracts have a lot of money at stake. So when you're writing smart contracts, and who here has exposure to smart contracts? Who wrote a smart contract of any kind? One person, okay. Who knows how the blockchain works from a technical perspective? Many people, okay, good, very good. So a smart contract, okay, one more question. Who knows how a smart contract works in particular? All right, so you were there at the talk yesterday. Okay, cool. So a smart contract is essentially one, like if you imagine a Google Sheet where you can edit values with a bunch of other people, you all see each other's edits, and you can all see who's doing what. Now, a smart contract is nothing but a Google Sheet on the blockchain where the only person allowed to change one cell's contents is the person who owns that cell. And that's it. Everybody can see all the cells, but only the owner of that cell can change the value of that cell. And that's basically what a smart contract is. So in that one big table, there will be values like this guy has this much ether, and this guy has this much ether. And if I change my value, if I decrease my value, I can increase someone else's by that exact amount. And that's all that happens when you interact with smart contracts on the Ethereum network. So you're basically changing a global spreadsheet, but in a limited way where only you have the ability to change specific values specific to you. So these smart contracts, these spreadsheets, can then be used for a lot of different stuff. So you can use it purely monetarily, so to send money to someone across the globe, or you can use it to register various items on the blockchain, like house deeds, like birth certificates, like marriage certificates, like, well, anything you can think of that basically owns to someone, that someone owns, that belongs to someone, you can put it on the blockchain and have that irrevocably sit there without the ability for someone else to take it away. There's no administrator to invoke super administrative powers. There's no owner of the database to change things. You know that whatever is done on the blockchain will stay there, and there's no way to move it unless the owner of that data moves it. So that's the aspect there. And smart contracts are very simple scripts, so they're not very smart, actually, and that's the wrong way to approach them. They're more like persistent scripts, like the creator of the Ethereum blockchain called them, Vitalik. So he called them persistent scripts instead of smart contracts. And that's what they really are. They're very short, very small scripts that execute certain logic, whether that's moving money or moving data, at a certain point in time or when a trigger happens. And that's it. That's basically it. You still need an external mover, so you still need to submit a transaction for something to happen. There's no way to automate this, because every transaction on the blockchain costs money. So it's all very manual, and it's a very slow and very impractical way to change data, but it's very convenient to store data forever. And that's the main advantage there. So, and that's also the main disadvantage of private blockchains. If you've heard of blockchains like Hyperledger from IBM and so on, we can discuss that a little later, but those blockchains are missing the point entirely. So this blockchain is there to make sure that the data is there forever and that it cannot be changed by some higher power. So, and these scripts are written in very simple languages. So Solidity and Viper are the main ones. Viper is very, very new and still being developed and quite undocumented. Solidity has been around for a while, and it's not exactly the cleanest language. It wasn't written by an academic. It was written by an academic more than a programmer, so it's kind of iffy, but you can write a lot of things in Solidity. And it has this limited set of operands, limited set of opcodes that you can deploy, basically a very limited language where you can do very little stuff, and there's a limited amount of logic that you can put in these contracts, because when you deploy them to the network, there's a gas limit. So if you're, for example, if you have a loop that goes on for a very long time, the network is not going to allow you to upload that, because every iteration spends gas, and gas is just ether in the Ethereum blockchain. And if you spend too much gas, you cannot upload your smart contract to the network, because there's a gas limit per block. So one transaction has to go into one block, and if you exceed the limit of a block, your transaction gets rejected. So you have to keep in mind optimizations, you have to keep in mind how much the deployment of your program costs at all times. And if they're so simple, then why even audit, right? I mean, if they're such simple languages where nothing can go wrong, I mean, where very little things can go wrong, why even audit? Why bother with this? Well, especially since they're simple and limited, you know, there's not a lot of functions. There's the system will automatically reject your program if it's too big and too complex. So there's no way to actually write something too complex to properly understand and audit yourself. So you would think that they're safe, but they're actually not very safe. And there are several reasons for this. One is the lone wolf syndrome, where everybody who's getting into blockchain development is right now a one-man army. And what you get is something like we had in the late 90s when the internet was booming. Anybody who was building websites did everything. So databases, servers, front-end, back-end, everything was done by one person, because it really was that simple back then. You didn't need 50 developers of JavaScript just to develop one single front-end page. You didn't need 75,000 frameworks. You didn't need 35 gigabytes of node modules dependencies to build a simple HTML page. Back then, you could write a website in Notepad on your desktop, deploy it to a server via FTP, and it worked. And that's kind of where we are today in the blockchain world. So if you were around in the era of emails beginnings, we had to send emails through command line. You had to write out your email in a DOS command line and write it by hand, send it by hand. There were no buttons. There wasn't even mouse interaction. You just had to type out your email and tell the program where to send it. And it was terrible. It was exciting, but it was very, very terrible for user experience, and it was not usable by the vast majority of people. The same thing is happening with the blockchain. So you have a lot of developers who are using this opportunity to get their foot in the door, but in trying to find their niche, their expertise, they're turning into this lone wolf who's doing absolutely everything on their own. Add to that ambitions and turf wars. Everybody's trying to get into this space now because it's so lucrative, even though the prices fell, and this is what many people seem to be focusing on. In the blockchain development industry, everybody's trying to get in because, well, first of all, the pay for blockchain developers is really, really good. Everybody needs blockchain developers, and essentially, if you want a career in enterprise blockchain, all you have to do is learn Hyperledger Fabric, so IBM's blockchain, for 6 months, put out 2 proof-of-concept applications that are basically demos, sit back and wait for a call. Within 6 months, you will be absorbed by IBM or bankrupted by them if you reject. They are not letting anybody do Hyperledger Fabric, anybody, without exception. Everyone gets absorbed because they want absolute monopoly over that system. So the pay is very good, the competition is fierce, and everybody's trying to be super ambitious and get their foot in as many projects as possible to build up that CV, to build up that experience, and to actually find and discover what they're good at and what they want to do in the blockchain later. Because when you're developing for the blockchain, you have the dApp side, which is basically like the web interface to the blockchain, so that's the Web3 stuff. There's the blockchain itself, so you can write a new protocol. There's the high-level blockchain, which is Solidity and Viper, so smart contracts. And there's a whole lot of stuff in between. And there might be a centralization aspect as well, if you need to relay some information. So you'll have a server in between, so you need DevOps backend and so on. So it's either small teams or even just one developer that's responsible for the entire project at this point. And no matter how many companies you see that say, we are developing this, we have developed this, it's basically just one person who developed everything. And it's usually just a lone wolf. Cooperation is very, very rare. People see each other as adversaries more often than not. So you'll find small companies or even single developers competing with each other, going behind each other's back. It's a very unhealthy ecosystem. It's super exciting, but it's a free-for-all Wild West where anything goes and you basically end up fighting everybody if you get into this space. If that excites you, I really welcome you to try. It's really, it can be really fun. And then there's the pressure. When you're developing a software on your own or with a very small team, you're frequently dealing with more money than small banks transfer in a year. A smart contract for an ICO, for example, can collect more than $200 million like Filecoin did last year. So Filecoin is a project that's trying to put file hosting on the blockchain and incentivize people to keep your data for you and to provide it back when you need it. So it's kind of like paid torrenting. And they basically wrote a single PDF as a white paper, a presentation for their product, and based on that, they got $200 million in a matter of seconds. If something goes wrong in that smart contract, which is receiving that money, there's no big red button to hit and to stop everything and say, whoops, let's fix this and redeploy. It's already out. So once those millions start bleeding away, all you can do is watch. And the pressure for that is immense. That is the biggest blocker for people to enter the blockchain space because it's very, very difficult to get past this barrier. Once people realize how much responsibility is on their shoulders, you frequently get developers who will just take on a project and then leave when things get serious. This happens a lot. It really does happen a lot. Sorry. And then there's the code blindness. Like when you've been working on a piece of code for a very long time, you become blind to any problems it might have. Not just blind, you become emotionally invested, and you also become very defensive about it, but not in a way when someone finds a bug and you don't recognize it, but more in a way, I don't even want to look for bugs because I'm that afraid of finding some. And I don't want to find bugs in my code because it'll mean I'm a bad developer. So I'll just trust that I did a good job and deploy. And this also happens a lot. And this is why we had some of the biggest hacks throughout last year, because people didn't pay much attention to what they wrote. They didn't ask other people about it. They didn't do the auditing. So, whoa, what happened there? OK, let's go back a little. Right, so the money is immense. And how many of you have heard of the DAO hack? No one. That's interesting. So last year, there was this concept called the DAO, which is a decentralized autonomous organization. So that's basically a smart contract on the blockchain network, which was supposed to be a decentralized investment fund. And people would send in Ether, and then they would get tokens in return. And tokens are just like virtual points, like collectibles, like loyalty points on the blockchain, where people would get those in return for contributed Ether to this DAO app. With these points, they could vote on decisions of the app itself. So the app was living on the blockchain without an owner, without an administrator. And when people wanted to invest the collected Ether into a project, someone would submit a proposal. They would say, I want to take 10,000 Ether out of this contract and invest it into this ICO. And then others would see this proposal, and based on the amount of tokens that they had, they could vote yes or no. And then the majority would win, and you would have some kind of a crowd-funded investment fund without an owner, without oversight, without susceptibility to SEC, to regulations, and so on. So you have this completely free investment fund, and everybody liked that idea. A lot of people chipped in. There was like 3 million Ether in the contract at one point. So a lot of people contributed. And the DAO was written by Christoph Jentsch, who was actually in charge of writing tests for the entire Ethereum network. So when you wanted to develop new software to add to the Ethereum network, you had to pass his tests so that your software would be considered a valid client. So he was like in charge of everything to do with testing. And he wrote this, and everybody trusted it. And he asked some people to give him feedback. And everybody said, yeah, this is cool, okay, let's do it. So 3.6 million Ether was lost because he forgot some function modifiers. He made them public when they should have been private. Was it an amateur mistake? Yeah, sure. Was he an amateur? No, he wasn't. He was a professional coder. But he didn't do enough auditing to make sure that this was safe. The attacker siphoned away the funds by making a recursive call where one contract called a subcontract of a contract and kept calling it, and basically kept siphoning a bunch of Ether every block that was discovered. However, there was a safeguard built in where all the Ether that was taken out of the DAO had a 2-week cooldown, so we were able to decide what to do about this attacker. And the decision was made, which was kind of controversial, because the rule in blockchain is you never change it. You never roll anything back. But the stakes were high enough that the blockchain could have failed entirely if this wasn't rectified. So what happened was the split from Ethereum to Ethereum and Ethereum Classic. Now we have 2 blockchains. Ethereum Classic still has this vulnerability in there, and the DAO hack still lives. The Ethereum that most people use does not. The funds were refunded, this hack was undone, and it was a lesson to everybody to be more careful. But you see that this can happen even to the proest of the pros. And so Christoph did actually ask some auditing companies to help him, but the fact was, back then, there weren't even auditing tools that could help you detect issues like these in the first place. So the only mistake he did was not asking enough people to check it out. So you make a kind of a weighted decision where if something has the potential to hold more money than it would cost to make X amount of audits, then you kind of do the audits. Otherwise, it's, you're in a net negative. So we can talk about the auditing tools, but since you don't really develop on Ethereum, I don't know if it makes much sense. But you can basically find all of these at this QR code. These are just some of those that we use at Auditor. So Auditor is a distributed team of auditors where when we get a task, we have people that are not localized. So they're not in one place. Everybody gets the same task, but they don't communicate until it's time to submit a report. Then the reports are compared so that most ground can be covered. And then you find the common points in every audit. Those are the most severe and obvious issues. But if they don't communicate, they can't influence each other's thinking, and someone might find an edge case that another one didn't think of. So this covers the most ground, and the more people we have on the team, the better it works. And these are all kind of just associates. It's not a fixed team. There's 2 of us that are constantly in it, but the rest of the team shifts around, and it's produced pretty good results so far. Still, in every kind of, do I have this? Yeah, I do. In every auditing job, humans are still the most important element, because you cannot find every mistake by just running machine code analyzers on your code. You have to be able to imagine a loophole, imagine an exploit, and then you can find it. Just recently, there was a bug. I'm sure, who's aware of the event stream bug? Okay, yeah. So just recently, like a few days ago, maybe weeks, within 2 weeks, I think, a popular NPM package was replaced by, so when you install packages into Node.js applications, you pull in dependencies from NPM, the package manager, and one of those dependencies was being loaded by a Bitcoin wallet. That Bitcoin wallet was loading the dependency without checking its contents. It just depended on it. That package that was being pulled in has been given over to another maintainer. So the original author had no interest in maintaining that package anymore. Someone else swooped in, asked, hey, do you mind if I take this over? I use it. He said, sure, whatever. He gave him the package. The new owner made some innocent contributions for a while, and then without being detectable, basically, he switched out a part of the code which let him, who was the owner of the package and now could change the code within it whenever he wanted, inject code into that Bitcoin wallet which was using the dependency, and steal the keys, the private keys to the wallets of everybody who had more than 100 Bitcoin. So we have like kind of a digital Robin Hood on the loose, and we have no idea how many Bitcoins he stole yet, or what's he going to do with them. But he was hunting big wallets, and he managed to take quite a few private keys within a week when his malware was deployed. So you have to be able to kind of imagine this attack in order to pull it off, because there are multiple facets, many factors to it, and it's not as straightforward as it might seem. So what I want to say is that not everything is a bug. Sometimes bugs are kind of intentional, and that's where Godmode Backdoors come in. So this is the other part of the talk, which goes beyond simple code audits and goes into more of these malicious people audits. So a backdoor is defined as something that may take the form of a hidden part of a program one uses. This is the simple Wikipedia entry. So now maybe we can, oh look, that's interesting. Where is my, okay, there we go. So if you played Doom in the old days, these are the cheat codes which let you do some things. So IDDQD was the best, was the biggest cheat code of them all. It gave you God mode, and it gave you admin access to everything. And the other ones are a bit lighter. So IDKFA lets you get all the weapons and all the keys in the game, and the first one just gave you all the keys. And we can compare this to some functionality which can exist in smart contracts, which we'll explain in just a little bit. So owner locks. This basically lets anybody, so a token, when you have a token in Ethereum, it's like a loyalty point that somebody developed. It's money made out of nothing, basically. Essentially, you have the spreadsheet with values that I explained earlier, but now the value is no longer Ether, it's just a balance of points, of arbitrary points that some private company made up. Some of these succeeded, some of these failed, but it's essentially just tokens, just money made up of thin air. And people put value onto these tokens, they invest in ICOs in order to, they hope that these tokens will rise in value and that they'll get rich. And owner locks are functions that let the owner of that contract, an administrator, lock all transfers. So the administrator stops you from being able to send the tokens. This is a common practice when an ICO, like a crowdfunding period, is over. So there's a cool down period, like a locking period, for the ICO to kind of gather information about contributors and check if everybody is allowed to contribute. This is in most cases legit, but it still is uncomfortable because it gives a lot of control to the admin who can leave the contract locked forever. So thereby, he can make the tokens inert forever and just keep the ether that was gathered in the crowdfund and run away with it. So this is an example. You have a function, disable transfers. It's just a simple Boolean flag, true or false. The owner-only modifier means that only the owner can access this part of the function, this part of the smart contract. And simply, the transfers enable function will get disabled, and you have here, this is a wrapper for that same function. A more interesting one is burning and minting. So the process of burning in Ethereum and smart contracts in general is the process of destroying tokens. So when you burn tokens, they stop existing. And some projects do this to increase the value of the remaining tokens. So if a project burns tokens, they basically give you some money because they make the rest of the tokens more valuable, because now there are fewer of them in the world. Minting, on the other hand, lets you mint new tokens. So it's like a gold mint or a government mint when they mint new coins. New tokens are created, but these minting and burning functions are unlimited as in terms of which account they can be attributed to. So in this case, this function lets the owner, again, owner only, lets the owner create tokens on any address that he supplies to the contract. So if he wants to increase his wife's balance, he can do it. If he wants to pump his own balance up, he can do it. Any address he sends in, he can pump up with new coins that come out of nowhere. This is a wrapper for the same function. And the same goes for burning functions. So destroy lets the owner of the contract, the one who deployed it to the network, destroy anyone's balance. So this lets the owner of the contract reduce someone's wallet balance, no matter where that wallet is. So your wallet security means nothing. If you have your wallet on a paper or on a hardware ledger or in a safe somewhere, it doesn't matter if it's offline, because you are just an entry in a spreadsheet. And this function lets the owner replace your value in that spreadsheet without you looking or without you allowing it. And then there's the owner admin who can do all of these things at once. So they can lock, they can mint, and they can burn at will, and they can basically do whatever they want with a contract. The examples of code here are from a live contract that is on the network right now and still alive and kicking, called Bancor. Those Bancor tokens are very popular. It's a very popular project. You can just Google for Bancor and you get a bunch of results. They actually were hacked a month or two ago, and they had to use these functions to restore the tokens. And the people who were damaged by the hack were at the same time very relieved, but also very shocked that they got their tokens back, because the project didn't actually tell them that the owner can do this. And what happened was, oh my God, we got hacked. I no longer have all my money. The next day, hey, look, I got my money back. Wait, if it's a decentralized system where no one has admin control, how did I get my money back? And suddenly there's a huge wave of disillusion with the project where people just don't understand how they got their money back or why someone has the permission to change their balance without them looking. Everybody kept saying, keep your cryptocurrency in a hardware wallet, keep it offline, keep it in cold storage, put it on paper, put your private keys on paper. So how can someone change my balance without me knowing? Similarly, all of these coins are alive, and all of them have had some interaction with these magic functions. In particular, the High Vibe network token was actually called out publicly because they didn't tell people that these functions are in their contract, and then they said, whoops, okay, and then they removed these functions. So they tried to sneak them in. And there's, like, if you own any tokens, or if you're going to own any tokens, it's very important to be aware of whether or not these functions exist in there. And if you can't recognize if they do or don't, you ask somebody who can. Because this can mean the difference between you just staying without, just waking up and all your money is gone. So, how do you find them? Study the code or hire someone to do that for you. Do not trust unverified smart contracts. When a smart contract is deployed to the network, there's an option in Etherscan, which is a site which inspects Ether transactions, to verify your smart contract code. You upload your code in there, it will compile it and compare it to whatever is on the network. If it matches, it'll get a green check mark and it'll say, yes, this is cool, the code matches. Only then can you inspect the code and be sure that it's identical to whatever they put on their GitHub page. Because whatever they put on their GitHub page is not a guarantee that it's going to end up in the blockchain network. So you need to inspect a verified contract on a site like Etherscan. Do not trust appearance. A popular project called Brickblock from Germany tried to tokenize real estate. They tried to, so they did what their plan was, they buy a building. They turn the building into shares in the form of tokens. People buy those tokens, and then the building's office space is rented. And people, in proportion to their owned tokens, get the profits from the renting. So that was their idea. They gathered, they made an ICO, so an initial coin offering, a landing page, they made all the marketing pushes. They even advertised that they had been audited by like 20 high-profile companies. And indeed they were. These companies confirmed it. They put the badges on their homepage and everything. And then, when we checked the smart contract address where people were supposed to send Ether to get tokens back, it turned out that it's just a private address. So there was a private address of one person, not a smart contract, nothing with logic. It was just one person's address that people were sending Ether to. So you have to check the destination where you're sending your money, and you don't trust pretty landing pages. In terms of code, look for only by and only owner modifiers, because these indicate special permissions for someone. But don't depend on them. The special conditions can be triggered by anything. I can put a function into the smart contract which says if someone sends me 666 Ether, then trigger something special. And this doesn't require special permission from someone, doesn't require an administrator, doesn't require modifiers, it just requires for that logic to happen. So you need to be able to read the source code. I also need to say that backdoors are okay, but only if public. So some backdoors are needed. If a government issues a stablecoin, like a digital, like a crypto dinar, like a crypto euro, like a crypto kuna, whatever. If a government issues this, they must have the backdoors because they want control over their own currency. What they get by putting it on the blockchain is automatic tax reports, automatic audits, transparency, and trust. But that doesn't mean that they have to relinquish control, because that would be stupid of a government to do. So, backdoors are okay if public. Backdoors are also okay for ICO security. Like during the ICO, if you have a backdoor, and if you tell people, I have this for security, and it's going away once the ICO is over, because the ICO will auto-close, that's also fine. Private companies are centralized anyway. If your company is building tokens, it makes perfect sense for the tokens to be private or administrable, because it just, the company is in control of the product anyway. So the Hanlon's razor approach is never attributed to malice that which is adequately explained by stupidity. Some dumb things in contracts can be just mistakes. So just don't assume that they had evil intentions if you find things like this in their code. But also never attribute to stupidity that which is adequately explained by malice. Do not assume that they made a mistake before thoroughly checking and asking them about this. Like, why do you have an admin function in your coin? And how do you guarantee that this won't disappear tomorrow if I invest? It's a very tricky situation, and the only thing that I can recommend is exploring smart contracts, diving into this code, which is very simple, and it's very easy to detect these things. You just have to invest a few days, maybe weeks, in order to be able to recognize these things. And it can save you and a lot of other people a lot of money. And if your company is planning some kind of ICO or any kind of, not even an ICO, but a smart contract in general for any need, do not skip audits. Pay a huge amount of money, as much as you need, to be really sure about your work. Because even 5%, even committing 5% of your total budget to a security audit is way cheaper than losing 100% later if you didn't do it. So be careful about that. Skepticism is always better than trust in this case, because a lot of money is at stake, and you can go very, very wrong, like with the DAO hack, which resulted in 3.6 million Ether lost, which even at today's prices is an unimaginable amount of money. That's it from me, and I would just like to tell you that we have a special discount if you want to learn more about blockchain programming. We are we're hosting a blockchain conference, blockchain developer conference in Croatia in less than 2 weeks, which is hands-on workshops and technical talks. So no investment, no nothing. If you want to come and learn and get some hands-on experience and talk to other developers exclusively about technical stuff, come to blockconf.io and just apply the GrowIT code for 20% off tickets just today and tomorrow for GrowIT attendees. Thank you. Any questions? Yeah. Who? Yeah. Sorry? In Čakovec. That's a little north of Zagreb. Yeah. That's why it's called Bločka. Yeah. No, of course. I don't. I refuse to work with any coin that has anything hidden from its users and investors. That's the, if it's public, then it's fine. If they have a valid reason for it, like if they say we're scared of a hack, so we need to have a backdoor in order to be able to hack our own coin. No, that's a wrong approach. There's an interesting thing that happened in Malta this year. They formed a new government agency called MDIA, which if you're launching a smart contract project in Malta, if you want to be kind of blessed by the government, you have to have a backdoor. And you have to give them access to the backdoor. And they have to be able to take over your project, take all your money, and refund everybody, or do whatever else they want, if you want to have their blessing and get a guarantee that your project will have a bank account. You don't have to do it, but then you're not guaranteed to get a bank account or a business license in Malta. So the crypto mafia at the government level is already forming, and it's getting some nice consequences there. Yep.
So that NPM thing, that whole NPM story,
Yep.
saying he's still at large, whoever this is, and then
Yep.
like how, because it seems like a really easy way to do this. Like, how would you prevent that from happening in the future?
Oh, well, he is still at large. He covered his tracks very well. The hacks that he did, the actual history of his actions on GitHub were very well hidden in quite beneficial commits. So he was doing good work before he switched it out for evil stuff in order to establish trust. Protecting against it, well, first I would recommend to everybody everywhere not to use Node.js in general. So Node.js is just, you're building a castle out of Legos and it's gonna break, it's gonna bend when it's hot, and it's just, it doesn't make sense long term. But if you have to, just some amount of thinking before pulling in a new dependency already solves the thing. You can also use lock files, which will lock your software to a specific version, but that doesn't help here because NPM is special in a way which lets you replace the same version of the file with different content.
So would any other package manager not have the same risks?
If you have a lock file, yes, every other package manager will prevent you from re-uploading different code to the same version number. If you have to do this with Node.js, just inspecting the payload that you're downloading and not just updating your dependencies blindly already helps. The only reason why this guy was discovered is because he used an outdated, deprecated function to steal the bitcoins, and that threw a warning to somebody who ran an update. And he was running an update, and that warning showed up. And he went to check, wait, why is this package using any kind of crypto thing at all? And he went to check, and he found that it's doing this. If he hadn't found this by accident, if he didn't make this mistake and use a deprecated function which threw a warning, nobody would have known until today still, probably, that this is happening. So locking your files to hashes of content at a given point in time is a good idea. Thinking before installing, and basically suffering from a bit of NIH syndrome, not invented here, is good here. You can develop most of these things natively in your project, especially if it's financially sensitive, because then you're in control of the code and you reduce the dependency tree by a lot. Because in Node.js, one package can pull another, which can pull another, and you end up with a tree of 50 gigabytes of dependencies for a simple JavaScript-enhanced web page, which is uninspectable. Instead, you can just implement it on your own. Like last year or the year before, there was the left pad incident where the same thing happened. Someone removed one package from the web, and that package, all it did was when you wanted to pad a number, so when you pad a number, you basically make it fit into a frame. If you have the number 100 and you need to pad it to 12, it will basically add that amount of zeros in front so that it fits into a database field or whatever you need. And that is all that this package did. But every other package depended on that package implicitly because nobody bothered to check anything. Nobody bothered to implement these 5 lines of code on their own. Everybody had to pull someone else's code. And then that one package disappeared, and everybody's builds broke. Why? Well, reason one, because people were pulling in ridiculous dependency trees for ridiculous things. And reason two, because well, I mean, let's be realistic. If your build system talks to the internet, you don't deserve any mercy anyway, because build systems should talk to downloaded and cached things that can build locally, and you should not depend on the internet to be able to build your program. And this is what NPM and Node.js do in general. So beating this is just basically reducing the dependency tree graph and just eliminating as many dependencies as possible, especially in applications that can hold 100 or 1,000 Bitcoins. That's just ridiculous, you know. Any other questions? Yeah.
Does the idea of centralizing cryptocurrency with these contracts for private companies, doesn't that clash with the idea of the blockchain?
Depends which idea. Some companies do have a legit reason to tokenize their service because they want to make their data available to the public without exposing their servers. Maybe they just want the free hosting that the blockchain provides. Maybe they have another reason. Maybe they want cross-platform loyalty points tracking. There's a startup called EngineCoin, which basically does cross-universe game items. So you can export an item from a game, a collectible from a game, and put it into any other game which is willing to support their smart contracts. And then you have the ability to, for example, imagine if you went to BlizzCon, like Blizzard's conference, and you came there with an item from Warcraft 1, a game that is 25 years old and has been defunct since, but you took an item out of it, and you have it on your crypto wallet, and you have it there for sale, a unique item from ages ago. That's similar to like trading card games where you have ancient, super valuable cards that people pay a fortune for. This is similar to that, you know. So there are use cases, yeah. Yeah. To use what? It depends on which framework you use and for what. In this case, yes, if you use Node.js, you are kind of bound to whatever you're pulling in, and you have to be very careful about it. But in general, frameworks, there are frameworks for building these dApps and decentralized apps and so on, which are very thoroughly vetted. And if you rely on those, you're fine, because the maintainers of those frameworks really do check these very religiously. These are Truffle and Embark. And these are two of the most powerful frameworks out there. And if you use any of those, you're safe. Yes, you have to trust them, of course. You have to trust them. Again, I would always say build your own stuff. It's not that complicated, you know. Pulling in a Web3 interface to communicate with the blockchain is a few lines of code, and you can build everything else on your own. And there's no need for build system. There's no need for ridiculous hacking around huge dependency graphs. You can do it on your own. It's just a web page. I mean, it's web development in the end. And let's not kid ourselves. It's not rocket science. Stuff goes into a box. Stuff comes out of a box. That's it. We don't need 200 megabytes of things for that. So, yeah. Hyperledger. Oh, yes. I mean, if you want to be an enterprise blockchain developer, absolutely. Hyperledger is not only a framework, it's a whole software suite of private blockchains that you can employ, and it's IBM checks it, so you're safe forever. Yeah. Okay. Okay, thank you.